Hello guys, in this video I'm gonna shed light on how to find or calculate the determinant of a matrix at more than 2 by 2 or bigger than or higher than 2 by 2 matrix. Okay, so I experienced some difficulty, like just like you guys when I just was preparing basically for that lesson. Of course, I studied determinant before many times, but basically, the problem that you're gonna face is basically some arithmetic, very silly mistakes. It's not like you don't understand or something, the topic or something in higher dimensions that you don't know or aware of. No, it's just basically arithmetic, very silly mistakes. Okay, even me, I have these mistakes when I do because you have many calculations. It's very easy to find to miss out like a sign or something of a number. So yeah, that's basically the challenges of these of kind of problems. Okay, so I figured out that the best way to do it is basically using some steps. I'm gonna shed light here that I usually do. You can of course not follow that and just use one method of that. But I usually do the calculation in many methods and even check on myself online. I'm gonna check now. Basically, there are three methods to find the determinant of a matrix. Okay, and all of them start from the first basic concept or calculus scheme, or way to follow the method one basically. So method one will lead you to method two, and method two will lead you to method three. Method one, the shortest, but the most error prone in my opinion. Second one, little bit longer. You reduce a little bit the calculations. The last one, method three, is the best because you reduce a lot the calculations and the determinant will be very easy to find. Okay, and even after that, I usually go online, and there are many online calculators that can find the determinant for you. So I check again on my answer. So basically, actually, if you do just the two methods and the numbers are matching, that's it. Okay, you don't even need this online calculator. Okay, so what am I gonna do right now? We're gonna start by the foundation. What we should do, basically, method one. So in method one, which is the standard, the foundation method, if you have like a matrix like that, first you laid off like the sign of each element as you learn it. It's a textbook of each element. So what we do, we choose a row or a column, and we find the determinant of the matrix based on that row or that column. Okay, in that case here I choose column one, that column one, ADG. Okay, so whatever the sign of each element in that column, okay, whatever the sign of A, whatever the sign of D, whatever the sign of G, in our final calculation of formula to find the determinant, A will be preceded by a positive, B will be preceded by a negative, G will be preceded by a positive, whatever the sign of A or D or G. These signs, the red signs that I put here, is not part of the actual number A. So A might be 5 or might be -5. You're gonna put positive in front of it, whatever the value of A is. D again might be, for example, 10 or -10. You're gonna put minus in front. So if D was 10, it will be -10. If D was -10, it will be +10 because of the minus. And same for G. Okay. So the basic formula, if we find the determinant based on column one, will be A, then you multiply A by positive A because we put a positive in front of it, by the determinant of this submatrix 2 by 2, EFHI. And how we do that, how we find the submatrix, basically you hash out, basically the column and the row, that the element that you find the corresponding submatrix, and the remaining of the matrix will be the submatrix. Like for example, for A here, you hash out the first column in which the first row in which E is located. You're gonna end up with EFHI. Then you're gonna do the same for B, for D. I'm sorry. So for this hashes here, matrix. So for D, we're going to do the same. So you're going to hash out the second row in which D is located and also the first column. So we're going to end up with B, C, H, I. B, C, H, I. And the same for G. Let's do it. So you're going to hash out the column. So I'm going to leave the column, but you're going to hash out the row, which is different. So the row will be this row here. So you're going to end up with this submatrix here. B, C, E, F. Okay, guys? Then, of course, you're going to find out what is the determinant of EF, HI determinant, and so on for the rest. It's easy. You're going to find the, the formula in the book. And also, I'm going to highlight it here, just in the second minute. Okay? So let's, clean up the mess before we go forward. Okay. That's the first method. Okay? It's very okay to use it. But usually you're going to have like some bad calculations or mistaken calculations. We're going to repeat a lot, review a lot. Okay? Let's now make it easier for us. What if D and G was zeros, or were zeros? If D and G are zero, what's going to happen? You're going to end up that the determinant of the matrix, let's call it A, will be only the first term here. Okay, positive A and the determinant of EF, HR. And so basically this will be cancelled out because it's 0 multiplied by anything will be 0. 0 multiplied by anything will be 0. And you're going to end up only with the first term, A determinant EF, HI. And how to find or calculate the determinant of a 2 by 2 matrix, it's basically a cross product like that. EI minus HF. Very easy. Okay? That's the second method. So if you somehow, I'm gonna see it right now when we have an example, cancel out D and G, basically make it like make D 0 and G 0, it's gonna be like 1/3 of the calculations will go away of the determinant. Basically, 2/3 of the sources of like issues in calculations will go away. So you reduce the probability of having like miscalculations. Okay. Now let's make it even easier. Method 3. What if H, this element here, was also 0? Okay? H was also 0. So you're going to have now H, D, and G will be are zeros. Again, if D and G are zeros, basically you're going to, cancel out these two terms, second and third term, the first big equation. Okay? But now look at, the last term that we have, which is the first term. So you're going to replace H by a 0. So that will be 0 here. So HF will be 0. So you're going to end up with the determinant of A equal to A multiplied by E multiplied by I. Where is EEI? Here is EEI. These 3 elements. Which as you see, located on the diagonal. So if you somehow given a matrix, and you could get rid of like elements D, H, and G, which is basically the element underneath, the main diagonal, then the determinant of the matrix will be just the multiplication of the elements on the diagonal. Very easy. Okay. So let's see. That's basically the general formula, that if you have a matrix which is called upper triangular matrix. When you have a matrix with all the elements underneath the diagonal are zeros, we call it upper triangular matrix. It's like a triangle. Okay, there is a triangle here. Look, guys, carefully. It's like we have a triangle. That's why they call it upper triangular matrix. Okay, so basically in that case, the determinant will be just the multiplication of the elements on the diagonal. In that case, we call it them AEI, so the multiplication is EEI. Very easy, easy peasy. Okay, so what I'm gonna do here in that example here, I'm gonna solve it with all the 3 methods. Okay, And maybe we have like miscalculations, just to make like it natural, just like you when you solve it. But of course, we're gonna like review. We're gonna also solve the other methods and see if where is basically our mistakes, if we do mistakes. Okay. So the first method basically is the first one, which is basically laying down, the main formula and just go for it. Okay. So let's see. A actually is this one. So let's write them down. A, B, D, F, G, H, R. Okay. So A, so positive, A is 1, and E is 1, F is 1, minus 1, 3. Then minus D, D is 3 in that case, and B is minus 1, and C is 2, then minus 1 and 3. Good. Then you have G, which is 2. Then you have B, which is minus 1, C is 2 again, and then you have 1 and 1, A and F. Okay? So equal to 1. 1 multiplied by 3, then minus 1 multiplied by 1. Okay, minus 3. Then you have minus 1 multiplied by 3, then minus 1 multiplied by 2, then plus 2, minus 1 dot 1, or like multiplied by 1, minus 1 multiplied by 2. Sometimes I put the dot, and sometimes whatever you like. Asterisk is much better, not to confuse with decimals. So let's continue here the calculations. So 1, and here you have 3, minus 1, and you have a minus, so it will be plus 1, minus 3, you have minus 3, minus 2, and minus, which is basically minus 2, minus plus 2, plus 2, minus 1, minus 2. Let's see, this is 4, and you have here minus 1, then plus 3, minus 3, 2 multiplied by minus 3, it's minus 6. If we calculate that, 7 minus 6 equal to 1. Okay? Equal to 1. I think this is correct because I know I solved it before, and it should be equal to 1. Okay? And we're going to verify, even if you don't know, and you did just solve it for the first time, we're going to verify by the second method and third method as well. Okay, that's method 1. So method 1 gave us 1. Okay, let's do it with the second method. Remember, in the second method, you somehow, you get rid of that 3 and you get rid of that 2. And it turns out, if you do like normal Gaussian eliminations, that's why Gaussian elimination is very essential. Very essential, You're gonna, when you do Gaussian elimination for the first, just the first column, you don't need to do like the whole Gaussian elimination just to find like, or to reduce basically, or to make all the elements under the main diagonal equal to 0 and reduce the form of the matrix to row echelon form. Just the first column only. Okay. So we're gonna try using Gaussian elimination to get rid of the 3, make it 0, and get rid of the 2 and make it 0 as well. So let's have a copy and paste here from that matrix and see what's we're gonna do. So it turns out, just let me continue here. And from you can refer back to our textbook. It turns out that if you reduce, if you do Gaussian elimination, that will not affect basically the determinant. Okay, the determinant should be 1. Okay, so what we're gonna do? So let's start by the 3. The first element or the first row will be the same. It's 1. Then you're gonna multiply the first row by 3 and multiply. And then subtract it from the second row. So basically, the equations that we're gonna have here are 2 row 2 new equal to row 2 old minus 3 R1. So this is R1, row 1, and this is R2 old, which it's gonna be replaced now by R2 new. I like to do that very like detailed so you guys can follow. Okay, so when you multiply this, it's gonna be 3. This is gonna be 3 minus 3 is gonna be 6. So 3 minus 3, of course, 0. This must be 0. 1 minus minus 3, it's gonna be 4. 1 minus 6, it's gonna be minus 5. Good. Now we're gonna get rid of the 2. So R3 new will be R3 old. And to get rid of the 2, we should multiply the first row by 2. So minus 2 R1. So we're gonna remove the mess of the yes. Okay. And R3 old. So when we multiply the first row by 2, this is gonna be 2 minus 2. This is gonna be 4. Okay. So 2 minus 2, 0. It must be 0. Something else happens, then you have a very, very big mistake, you know, because we are reducing it to 0. We want it to be 0. Minus 1 minus minus 2 will be plus 1. Then 3 minus 4 is minus 1. Okay, that's basically, you know, just one step Gaussian elimination, and we get rid of all like the elements underneath the first element in the first column. Okay, now we can find the determinant. So the determinant, but when you find the determinant, look at this matrix, not that one. Okay, so again, if you calculate based on the first column, you have only one element, which is the 1. So let's hash out, let's change the color. Let's hash out the first column in which the 1 is located, and the first row in which the 1 is located. And remember, the sign of the first element is positive. So we have positive. And let's go back to our normal color. So positive 1. And submatrix is this one here. 4 minus 5, 1 minus 1. Equal to 1, 4 multiplied by minus 1, minus 1 multiplied by minus 5. Why I'm doing it so detailed like that? Because if you have a mistake, you can trace easily where is the mistake. Okay, you can just look at the detailed intent of the calculation. Basically, we're gonna write it all down, you know, and you're gonna find out which is wrong, the signs that you missed, numbers that you type it incorrectly, and so on. So that will be minus 4. It is minus 5 plus 5, which is again plus 1. Matching is the first method. So we are very correct. Okay. Let's now do the last method. Okay. And the last method is really interesting because you already did part of it. Okay. When you do the second method, when you do the second solution, basically. Okay. Because what you need in the last method is that all the elements underneath the main diagonal equal to 0. And if you look here, you already did part of that in the second method when you make like the 3 and 2 to reduce to 0. So what's left off here is basically this one. Okay, just this one. So what I'm gonna do right now, I'm gonna just take copy and paste that and continue on it. So let's have that here. So that's basically copy and paste. Fine. And the copy and paste also from that one here. We can like clean it later, that's fine. Nice. Copy. Paste. And we can have some cleaning here. Very fine. Good, good, good. Okay. And continue like that. All what we need to do now is to reduce that guy to 0. Okay. Just also for cleaning. Okay. So what we're gonna do, we're gonna continue our Gaussian elimination. Okay. But now we're gonna look at the second row and the third row. Okay. So What we're gonna do is to reduce this to 0. So we're gonna multiply the second. Actually, there are two solutions. So two ways to do it. Okay, I'm gonna do both, by the way, because some of you did that. So I'm gonna just because they are same, but this is what I prefer to do. So some people here, just doesn't look at all at the matrix and just continue, which I belong to in that group, just to continue. So what I'm gonna do, I want this to be 1. So I'm gonna multiply the second row by 1/4 quarter. Okay, so this is the new matrix: 1 minus 1 2 0 4 minus 5, and now the third row R3 new equal to R3 old minus 1/4 R2. Okay, so if we multiply this guy by 1/4, this will be 1, and this will be minus 5 divided by 4. Leave it like that. Don't even try to calculate. Leave it like that. Okay. So what's we're gonna have here? Let's calculate and see. So 0. Of course, the 0 here will be still 0. So don't need anything. 1 minus 1 is 0. That's what we wanted actually. And then minus 1 minus 5/4. So it will be plus. Write it like that: minus 1 plus 5/4. Reduce it later. Don't panic. It's very fine. Okay. How to make that like reduction? It's very easy as well. Let's do it on another. So minus 1 plus 5/4. That's very easy. The 1 can be written as 4 divided by 4. So minus 4 divided by 4 plus 5/4. So 4, and this is a quarter. Okay, so we can remove that guy here and write 1/4. Okay, so that will be 1/4. Okay, and here you have it. Here you go. You have an upper triangular matrix because basically all the elements underneath the main diagonal just reduce to rebels, zeros. Okay, so the determinant now will be the multiplication of all the elements on the main diagonal. So which is 1 multiplied by 4 multiplied by 1/4. 1/4. Of course, this cancel out. This will be 1. Okay, easy again. And that's I like this method because, and usually I have like preference to it, a bias to it. So whenever I have a question like find the determinant with no like explanation or like instructions, what kind of area or what kind of of method to use, go for this one. Okay, I see it, in my opinion, the most, the easiest way to do the determinant. Okay. Just a side note here. So of course, again, we get 1. That's basically the final, the correct answer. Some people here, especially in that, step, have like a tendency to switch the rows of. Let's do it. That's fine. Usually we like to have the element on the diagonal, the ones that we refer to, the ones that we subtract from, like in that case here, row 2 as well. So what they do, they switch the rows. So first row will be the same, and then they switch row 2 and row 3. So row 2 will be 0 1 minus 1, which was row 3 before, and row 2 will be row 3 will be row 2, the old row 2. 0 4 minus 5. But if you do that, you have to add a sign in front of the determinant. So all your calculations will be multiplied by -1. So any switching of a row will be any switching. If we switch 2 times, then they cancel out. It will be minus. So it's positive. Okay, here we switch 1 time. So it's gonna be minus. Okay, and then you continue. So what we're gonna do, we're gonna multiply that row by 4 and subtract it from row 3. So the matrix will be the same. second row will be the same. I'm sorry, the first row will be the same, second row will be the same. Then the row 3, R3 new, will be 4, I'm sorry, will be R3 old minus 4 R2. This is basically R3 old. Okay, and this is R2. So R2, when you multiply it by 4, of course, that will be 0. 4 minus 4. Okay, and then we go back to our normal color. So 0 minus 0 is 0. 4 minus 4 is 0. Minus 5 minus 4 will be minus 1. Okay, and again, here you have it. Here you go. You have an upper triangular matrix again. Okay, so the determinant of A, this is much easier. You know, it's all ones. Remember, you have a minus here. Minus. Okay, then 1 multiplied by 1 multiplied by minus 1. So it will be minus 1, which is again positive 1. Okay, I personally, go with this. I usually multiply by quarters and stuff like that. Rational numbers. Okay, that's fine for me. Okay, but if you afraid of again miscalculations, just switch the rows. Okay, but for any switch you do, you add a minus. If the total number of switches is odd, you're gonna end up with a minus sign. If the total number of switching is even, you did nothing basically. So it's gonna be positive at the end. Okay, so that minus here, why we added? Because we switched row 2 and row 3. But again, I usually go with the first one. It's much easier, much easier. Okay, and yeah, and that's my preference. Whenever you have a determinant equation, just to go with the reduce the matrix to make it like upper triangular matrix, and here you go. The determinant will be basically the multiplication of all the elements on the main diagonal. Now, let's check out an online calculator, okay, that don't just give you the final answer, which is 1. It also detailed for you all the steps, to find out the determinant. It would be very, very detailed, So I'm gonna leave the link for that in the description, the link of this online tool. So let's have it here. Actually, I think I solved it already, but let's check. So I'm not sure if this is the one. Yeah, I believe it is. We're gonna end up with 1. Yes, it is. So let's check out here what methods they did. Okay, I believe they did the upper triangular method. So they start up with the main matrix, our matrix. Okay, and yes, they try to reduce what they did. Yeah, they try to make it like upper triangular. Let's check the final answer to see. Yes, they try to make it like upper triangular matrix. Okay, so let's check out, just highlighting very quick what he did. So he get rid of the 3 and 2. Okay, so he multiplies the first row by 3. Okay, and then subtract it from second row. Second row reduced to 0. And of course, don't forget to retain back, or write. The first row should be written the same all the time. Okay, he just multiply by 3 here, just for the sake of calculations, to show the row after we multiply by 3, but it doesn't change. So it was 1 minus 1 2, remain 1 minus 1 2. Then he multiplies the first row again by 2. This is just for reference. So it becomes 2 minus 2 4, and subtracted from row 3, and again row 2 should go the same, should become the same. 0 0 1. This is after the calculation. Now he can just stop and find the determinant of that and multiply it by positive 1. That's of course correct. But he just continue forward and reduce this 1 to 0 to make it upper triangular matrix. So what he did what I did. He multiplied this row here by 1/4, a quarter. So this stays 0. This become 1. This become minus 5 over 4. Okay, so that become 1/4, a quarter basically. Okay, then he multiplied. Remember this. Yeah, this is after. So this is after the multiplication. Remember again. when we multiply a row by something, by some factor, we keep it like only in the effect will be shown in the for example here in the third row, but the second row will be stay the same. Okay, so it erodes the same here. Okay, so that's basically for the matrix after reducing it to upper triangular matrix. So it become 1, 4, 4, 1/4, 1/4. Then you multiply them together and it gives you basically 1. Okay, so that's it. That's it, guys. You have 3 methods. You have also the online calculator, you know, and of course, use the online calculator only to check on your answer. You know, don't use it from the first as a first choice. Okay, guys, thank you very much for watching and see you in another video. Bye-bye.